Respiratory systems, there are a variety of things, as we've seen for other types of body systems. Some animals do not have anything special there. Things like sponges, the cnidarians, the flatworms, their body is enough in contact with air or water that enough gas comes in, goes out to maintain what they need. A number of more complex animals, however, have specialized structures such as gills or lungs to help get the gases in and out that are needed. No surprise, circulatory and respiratory systems will be associated with each other, assuming that an organism has both of those. Animals typically have some way of trying to move either air or water across the surfaces where they're absorbing oxygen and releasing carbon dioxide and sometimes other waste as well. So that's just the general body surface. Some have special tubes, some have gills, some have lungs as the key areas for getting oxygen and releasing other gases. And these in turn will tend to have a strong supply of blood vessels to help with the gas exchange in these areas. Breathing air, well, it sure works for us. Lots of oxygen in it, so it's easy to get a good supply of oxygen if you breathe your air. Diffusion happens faster in the air than in the water, and air is easier to move. However, oxygen will not be absorbed to a dry surface. We need to have fluid for the oxygen and the carbon dioxide to be absorbed or released on our surface there. Okay, keeping the surface moist. Why does that matter? If you're in the air, you can get dried out. But the surface has to be exposed to air to get the oxygen. So there has to be some way of keeping this surface moist if you're breathing air. Some organisms are able to breathe through most all of their body surface or specialized regions of it. Say, for example, either end of the digestive system. You have some things that use the inside of their mouth as an area for breathing. You also have some things that use the other end for breathing. For example, turtles, of course, they have lungs. They're reptiles. They breathe air. They do not have gills. But come wintertime, a lot of our pond turtles will head down to the bottom of the pond and hibernate there. Underwater all winter. How is it not drown? Well, it's not very active. It's not using much oxygen. And it turns out the turtle is able to absorb enough oxygen for just sitting there doing nothing through water coming into its rear end. And it absorbs the oxygen through there and releases the water back out, and that it gets by on that. This giant salamander here, the skin is wet. It lives in cold streams. High levels of oxygen. It's able to absorb most all the oxygen it needs from the water around it. Whatever surface we're using to get oxygen, we need a high surface area to pick up lots of oxygen from the air or water. Just relying on the body's surface rather than more specialized lungs, that's not the greatest supply of oxygen though. So that generally goes along with not having a very high level of metabolism and activity. And again, you need to stay moist. So many mollusks are able to do this. Many types of worms, a lot of amphibians, fish, even some reptiles have some ability to absorb oxygen through their skin. Now, of course, a lot of those also have gills and lungs, but are able to pick up oxygen just from the body's surface. If you live on land, that surface has to stay moist. So you have to be putting out fluid, which means you have to be drinking plenty of fluid. Land arthropods characteristically have a set of tubes sticking into the body, known as tracheae. And so air goes into these tubes and reaches the parts of the body carrying the oxygen they need. So there are little row of holes on the side of the body, and air can come in through these holes. There's often some degree of muscle, but not a huge amount. Largely, they're just depending on air drifting in and out again to bring in the oxygen, take the carbon dioxide out. If these little tubes get too long, air does not move in and out enough, and the animal won't be able to breathe. So this limits how big an insect or millipede or other land arthropod gets. Gills, living in the water. These will be some sort of thin, moist structure that extends out from the general body surface. These may be kind of covered up, like in most fish, internal gills, or you can have them sticking out of the body, like in certain amphibians, like this mud puppy here. We've got an endangered mud puppy species in eastern North Carolina, the noose water dog, for example. Lots of different styles of gills. A number of worms have these. Most mollusks, snails and clams, cephalopods, things like that live in the water have them. Arthropods that live in the water have gills, fishes, many amphibians. Gills, since water is going past them, they can also sometimes be used to trap food, filtering as well as picking up the oxygen. Gills have to stay quite moist, so most things with gills live in the water. You do have a few things up onto land, but they have to keep their gills moist or else they'll die. For example, the little roly-polies or pillbugs, the isopod crustaceans that are among the common things that you can find if you pick up a log or rock or something. They actually have gills, and so they have to stay damp. They're relatively vulnerable to drying out. Lungs are internal structures with high surface area that the animal can bring air into, and then there's fluid moving around it, and that will pick up the oxygen and release the carbon dioxide. Lungs are present, of course, in many vertebrates, in the mammals, in the birds, in reptiles, in most amphibians. A number of fish, such as the lungfish, have them. There are also a lot of the snails. Most of the snails that you see on land have lungs. For example, many spiders have a sort of lung. Now, if you're an ectotherm, cold-blooded, you're breathing air with these lungs, you're getting a lot of oxygen. So they tend to not need to constantly be breathing, just from time to time, oh yeah, I'm starting to get low on oxygen, let's go get another breath. Birds and mammals, on the other hand, warm-blooded, need lots of oxygen all the time, so we need our lungs to be very efficient and constantly breathing. Birds and their relatives, the dinosaurs and even crocodiles, have a somewhat different pattern of lungs than what we do. They have an extensive set of air sacs through much of the body, and so these are used to help move air through the system. In this case, air comes in, goes into air sacs. Breathing out, that air moves into the lungs. As the bird breathes in the next time, that air moves on into additional sacs, while of course that air that just breathed in moves into the other sacs. And when it breathes out again, that air in the front sacs moves out. So this has different in and out from the lungs. This is very efficient. In us, we breathe in, we breathe out. Air is going up and down in the same tube. A lot of that air that was down in our lungs and now is rich in carbon dioxide doesn't make it all the way out before other air comes in on top of it. Not the most efficient way to get all the oxygen that we could out of the air and get rid of all our old carbon dioxide rich used air. Now, it's good enough. We can function, we can move pretty fast, but it's not as efficient as in birds. So this is a good way of getting a very high supply of oxygen. One of the things that helps birds to be so active is to actually fly. Air sacs, having lots of air sacs in the body, that's also kind of handy for the birds for flying, because air sacs don't weigh much. And so this system of air sacs in the body makes them much more lightweight, eat better for flying. You may notice if you see a squirrel in the trees, the branches are doing this. A bird that looks as big as a tree lands and the branch does that. The bird's much lighter weight than the squirrel with all those air sacs in it.